In this lesson, we're going to learn about scatterplots and trend lines, and specifically what's called a line of fit or line of best fit, positive correlation, negative correlation, and no correlation. I know that you've seen scatterplots before, but I'd just like to review quickly what the definition of a scatterplot is. A scatterplot is a graph of a table of data in which you're comparing two variables and you plot the data as ordered pairs. So in this case, if you're comparing the number of hours of homework that a student does per week to the grades that they get, there would be a set of ordered pairs, one for each student. The first number in the ordered pair would be the number of hours of homework that that student did, and the second number might be the grade that that student got at the end of the term. When we plot each one of those pairs as an ordered pair on a coordinate plane such as you see, that is a scatterplot. Now, to understand the concept of the line of fit, I'd like you to imagine the following situation. I want you to imagine that on a target such as this one, I drew a line that is no longer there, and I asked people throwing darts at the target to aim for that line. And the question is, where do you think the line is? Now, if you look at the first target, it's probably pretty obvious where the line is. The line is probably right about over there. That's because we can assume that the person who was throwing the darts was a good shot and he came very close to the line every time. In the second graph, we see that the dots are a little bit farther apart. And in this case, it's not as easy to tell where the line is. Now we can place the line maybe here, but there are a lot of other ways that it could go. It might perhaps be up a little more, down a little more in slope, or it might be up a little higher or down a little lower. It's harder to tell because the dots are not as close to one another, and the person who's shooting is probably not as good a shot. In the third case, it's almost impossible to tell where the line is. It might be over here, but it might go up like this, might go down like this. It might be positioned in other ways, such as a little higher or a little lower. You really can't tell. Now, one reason for doing a study that maybe compares hours of homework to grades is to find a formula for predicting, based on how much homework a person does, what their grade is likely to be in this class. The formula is actually the equation of a line, and in this case, the equation of the line that best fits the data from the study is called the line of fit, or the line of best fit. Another name for that line might be trend line. All of those terms pretty much mean the same thing. Now, in this data, if we were to use the data and our estimation skills by looking at it, we might think that a line of fit might go there, and that if we were to write an equation for that line, we would be able to plug into the equation the number of hours of homework and get out the grade that the person is likely to get in this class. Now, the problem with just drawing a line using estimation given a set of data is that if 4 or 5 people take the same set of data and estimate a line, it's likely that each of those 4 or 5 people will get a slightly different line. And what we would want is to have a way of enabling everyone to get exactly the same line. So there is a mathematical method of doing just that, taking the data and finding the equation of a line of fit. And your calculator implements one of those, and we'll be learning how to find the equation of a line of fit using your calculator. Next, we're going to look at the concept of correlation. Now let's imagine that a teacher wanted to find out if the amount of homework that a student does per week is related to the grade that they get in class. And the teacher may collect data on the amount of homework that the students do, and then take a look at their grades and see if they're correlated, see if the two variables are related to each other in a meaningful way. Now, let's say that one teacher did this study in her class and got this data shown in the first chart. Now you can see that the amount of homework that students do per week looks like it's directly related to their grade. And the less homework people did, the less of a grade they got. The more homework they did, the higher the grade. In this case, we say that the two variables, homework and grade, have a high positive correlation. It's a high correlation because the data points are very close to a straight line. And it's positive because the slope of this line is positive. Now let's take a look at a second case. This teacher again studied the homework hours and the grade, but got different data. Here, the correlation between homework and grade is not quite as close. You can still see that it's there. There's probably a line of fit that goes through this data, but it's certainly not as close as the first teacher got. In this case, we also say that there is a positive correlation but it's not quite as high as in the first case. Now one more teacher did this teacher down here, and here would be the homework hours, and here would be the grades. And for this teacher, it looks like there's almost no correlation at all, that it didn't matter how much homework students got. By and large, some of the students who did very little homework got high grades, and some of the students who did a lot of homework may have gotten low grades. So here we might say that there's either low correlation or no correlation. Now in statistics, we actually put a number to correlation. In other words, we can give a numeric value to the amount of correlation. So let's take a look at that. Now in this class, we're not going to use the formula for correlation. We're going to let a calculator do all the work. But what we will try to do is understand what the correlation means. Now the correlation is always a number that goes from -1 to 1. It will always either be -1 at the lowest, 1 at the highest, usually somewhere in between. As an example, a data set such as this is a positive correlation, so the correlation number is going to be positive. And since this is a good correlation, correlation is going to be very close to 1. In this case, the correlation might be about 0.9. In the second graph, the correlation is lower, but it's still positive, so it's going to be a positive number, but the correlation I would estimate is somewhere in the neighborhood of 3/4 or 0.75. And in this last graph, we would say that there is very little correlation. There might be a little bit, so we might say that this correlation is around 0.1. Now you might ask, what is a perfect positive correlation? What does that look like? This picture shows a perfect positive correlation, and we assign a value of 1 to that correlation. So when all of the data line up perfectly on the same line, and the line has a positive slope, we say that there is a positive correlation of 1. Now in this study, the teacher matched the number of TV hours that students watched to the grades that they got in class. And let's see what the data look like. Now in this first case, the more television that the students watched, the lower their grades. So the grades started high, and they got with little TV watching, and they got lower with more TV watching. Now because the slope of the line of fit is negative, we also say that the correlation is negative. And I'll draw in a possible line of fit. Might be something like this. And but this is definitely a negative correlation. In this second graph, we also see a negative correlation. If this is the amount of TV that they watch, and these are the grades. Then this also looks like a negative correlation. In other words, the more TV, the lower the grades. But it looks a lot better than the first one. So this is a higher negative correlation. And then this last graph of television versus grades really looks like there's no correlation. People who watched little TV got high grades and low grades, and students who watched a lot of TV got some high grades and low grades. Now if you look at the data in the first graph, the data are very closely correlated, but the slope is negative. So we say that that has a negative correlation, and in this case, because it's reasonably close, we might say that it has a correlation of about 0.85. In the second graph, you'll notice that the correlation is also negative, but the data is a lot closer to that line, so the correlation might be negative 0.9. In the third graph, it looks like there's almost no correlation at all, and if there is none, we would say that the correlation is 0. Finally, the graph at the bottom left represents a perfect negative correlation. A perfect negative correlation is said to be a correlation of -1, and you can see the data lines up perfectly with negative slope.